Let's start a discussion of properties of the real numbers by reviewing the various subsets of the real number system. We'll start with n. N is the natural number system. Natural numbers, or counting numbers, are just 1, 2, 3, 4, 5, etc. Then there are the whole numbers. The whole numbers are the natural numbers, but with 0 included for the first time. Then we have z, the letter we usually use for integers. And integers are positive and negative whole numbers, again including 0. We have rationals after that, which are fractions, a over b, where a and b are integers, but b is not 0, because we know we can't divide by 0. We can't put 0 in the denominator. Then there are irrational numbers, which are numbers that cannot be so expressed as fractions, and all of those numbers together become the real number system. They include all the rationals and irrationals. In each one of these sets, every natural number is also a whole number, every whole number is also an integer, every integer is also a rational, every rational is also a real. And they can be represented on real number line. We can just draw a line and identify 0, and from there we can identify any other point in the real number system, any number represented by a point somewhere on this line. In addition to this, as a beginning, we want to talk a little bit about set notation. If we're going to discuss set notation, we want to talk about this sort of notation. We would read that the set of x such that, vertical line, such that. And then we'd write conditions in here. The set of x such that, we might write in here, x is even. And then we know we had to have even numbers. We might put in here that x is less than 5. We might even put something in here that's a compound condition. X is less than 3, or x is greater than 5. Then we would know on the number line to find 3 and to find 5. And we know that we would want to be less than 3, so we couldn't be there, but we could be down below, or we could be not on 5, but above. This kind of diagram and this or statement is often called a union. We also might have another setup that looks a lot like this. Another compound setup would be x is between -2, say, and 3. This can be also read as an and statement and becomes something known as an intersection. The graph of such a set would be going to -2 and finding 3. And because we have or equal here, we would be allowed to use the -2, so we would color that in. And we could not use the 3 because it's open. So that we draw it like that. It's not allowed to equal 3. But we can use anything in between. So you have these two kinds of combination sets drawn on a number line. And can be written like this. That's called an intersection. And see what it looks like on the graph. and the other one we did is union.